Hi, this is Sui778 coming at you with yet another multimeter review. And today's flavor is the Thsinde / WinAPEX 128C compact multimeter. I got this at Amazon.com for around $23, and the link to the product is in the description below, as it always is. So let's go ahead and get to the unboxing. So first we have kind of a small box, kind of a pretty box, I guess. Has some stuff here on the back, although I would say this information is not 100% correct, and you'll see it talks about current, but we'll get to that. This meter doesn't do current. So let's go ahead and open it up. Let's see what we get inside. Now first we get a set of batteries. And looks like it's all going to come out in one, so let's just go ahead and pull it all out here. We get a user manual, which is, I'll show you some of the specs here real quick. Here's all what it could do. I think I got some specs here somewhere. Yep, here's some specs here. Some more specs here. And let's see if we got any more. We might have a little bit more. Nope, that was it. Anyway, this meter does come in both Chinese and English. So if you open it up and it displays Chinese, just flip to the back of it and you'll get to the English version. Okay, next we get a nice little carry bag for this. Feels like it's made out of vinyl or whatever. I don't know. But seems like it might be waterproof too. And last but not least, we get the meter itself. And yes, this is a meter that has permanently attached leads, as you can see. And this is another compact one, and when we get to the overview, I will show you a comparison in size to the Kaiweets HT112B, since that's the most similar one that I have. Okay, now there are three variants of this particular model. As you can see, it says WinAPEX on it instead of Thsinde. So my guess here is that WinAPEX licensed Thsinde to sell this. I have no idea. But anyway, but there are three variations of this, as I was about to get into. This is the 128C model. There is the 128A, which has a standard LCD that is backlit, and then a 128B, which is an EBTN like this one is, that has, it's just black and white. And then this one is a tricolored version. It has, can't remember what the colors are right off the top of my head. It's like white, kind of a bluish color, and a reddish color, I think. But anyway, it is three distinct different colors. Alright, so let me get this set up as best we can here, and we'll do an overview. Okay, now that I got it set up here, just a quick overview. These are what you would call touch-sensitive buttons. Basically, you just have to apply a little bit of pressure to them. When they are in use, they are backlit. As you will see, these will light up when we turn this on. So we've got our power and a toggle between putting this unit in auto mode, and I do believe this will cover all of the measurements when in that mode, except for NCV and live. You have a dedicated button over here on this side for that. You also get a dedicated capacitance / flashlight button. Not sure why they did that, but there it is. And of course, then a freeze frame hold right here. And to power this on, basically you just need to press and hold this slightly, and it comes on. Has a fairly loud beep. And just to show you, as you can see here, these leads, let me pan out a little bit. As you can see, these leads are permanently attached, so do be aware of that. Here are the leads themselves. They're a little bit on the short side. Not sharp, but not too blunt either. They seem to be okay. I played around with these before I started shooting, so we'll get to that, the qualities of these later. Let's go ahead and go through the modes real quick. As you can see, when you first power it up, it does display the temperature. This does have an onboard thermal probe in it, and that's basically it. You cannot, you won't be able to measure temperature with these. Anyway, so it does default to auto mode, where you can do all your different measurements. You can also scroll through them by hitting the button down here. There we go. Okay, so you get your DC volts, AC volts, and this does say it's true RMS. Okay. Got your continuity and diodes, capacitance, frequency, and it looks like the auto mode is the only way you're going to be able to measure resistance. Okay. Anyway, moving right along. Let's go ahead. I do like this display. It does have a nice tricolor. You're only going to see the red come across here when you're using the live function, but you do. This is kind of like the other Thsinde that I had, where it kind of had like the teal colored and then the white. So it's a decent display to look at. It's also relatively clean. Let me zoom in on that. And again, as I will show you here, the lights do light up when you turned it off. Didn't want to do that. But as you can see, they did light up. So that's okay. Let's go ahead and take this apart, and we'll show you what's going on inside. Okay, so first let me go ahead and show you the battery compartment. It is located right here. It has a Phillips screwdriver in it, so let's go ahead and take that out. This does come with a pair of AA batteries. They are included, as you saw in the unboxing. And that's basically all she wrote right there. I had already stuck some batteries in from something else. And then to take this apart, it looks like you have these four screws right here, 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 and here. So let's go ahead and take that out. There we go. All right, finally got that open. That's not that easy, even with the guitar pick. Okay. So let me get set up here, and we'll do a close-up on the PC board here. Okay, now for a close-up of the PCB. On the left here we got the battery case. Looks like the leads for the batteries are coming in right here. For the leads for the probes are coming in, right here, and it looks like they're running underneath the battery compartment and then hardwired here. Looks like we've got a single PTC, a couple of resistors in series here. As you can see, there are no fuses anywhere to be found. Not really any diodes anywhere to be found either. I mean, here's some LCD diodes, but those are just for the backlights on the buttons on the front. Looks like the jacks for the calibration are right here. Got a couple of good-sized capacitors here. Here's the relay for the auto. Here's your main processor. There's the LCD controller, or I should say EBTN controller. Speaker. The NCV is up here somewhere, maybe on the other side of the board, and I am definitely not going to pull this out. This thing was a real pain just to get it open to this point. And that's basically it. It's pretty simple design. It looks like it was built in the 40th week of 2020. And the revision on this is, looks like, let me get a flashlight on it so I can actually see it. It is, looks like June the 4th, 2020. Okay, so fairly recent revision. All right. Not much else to say about it, really. It's pretty simple, straightforward, no fuses, no current shunt. This thing doesn't do current, so I was kind of expecting to see that. But there you go. looks put together fairly well. The soldering job up here is a little bit sloppy on the leads. Otherwise, the rest of it looks all right. All right, let's go ahead and put it back together and do some measurements. Okay, before we start doing measurements, I wanted to do a little bit of size comparisons. A couple things I left out of my notes, and also the divergenization. So here is my Kaiweets HT112B, and here is the Thsinde 128C or WinAPEX. As you can see, they are quite similar in size. I mean, they're almost exactly the same size. Let's see, just put this over that, and yeah, actually the Kaiweets is a little bit smaller, just a hair. Here's the other major difference between these two. As you can see, this one's got a protective glove on it. This one does not. This just has a hard plastic case, and that's it. You do not get a protective cover on this at all. This is a 6,000 count. I don't remember whether I mentioned that or not, but this is a 6,000 count multimeter. And let's see, what else did I forget? The protection. I'm just going to say it has minimal protection. I mean, category 2. I don't know if I could even call this category 2 250 volts, truthfully. I wouldn't use it for that high a voltage, but anyway. All right, so let's go ahead and de-virginize it. Let's take the cover off like everybody loves. So let's go ahead and do that real quick. At least they made it easy for me. So let's go ahead and peel that off. Come on. Yeah, it was trying to come off on me earlier. Now it doesn't want to. There we go. All right. And look at that. Looks nice and pretty. And I can tell you one other thing about that. That display is probably going to be a total fingerprint magnet also. But there you go. All right, let's go. Now let's go on to the tests. Okay, and here we go with the DC voltage test. I had to get a little bit creative since this had permanently attached leads to it. So I just pulled out some alligator clips and did it that way. Then, of course, we're running to the reference meter. And just so if anybody wondered, yes, I run the reference meter last in this series. Always last when I'm testing another one. So anyway, let's go ahead and plug this in and see what it does on voltage. And this is 2.5 volts. And we are showing 2.502. Okay, yeah, not too bad. All right, let's go to 5. Okay, again, we're getting 5.01. It's slightly high, not horribly off, but yeah, a little bit high compared to the reference. But all right, let's go to 7.5. Okay, we're getting 7.50. 7.49. All right, not too bad. Oh yeah, I forgot to mention this does have a, I don't know if you can see it in the display or not, but it does have a bar graph. It just follows the speed of the number, so it doesn't really matter. All right, so we're getting wavering between 7.49 and 7.5, so that's not too bad. All right, let's go up to 10 volts. Okay, we're getting 10.00. So I would say this thing is actually pretty decent on voltage. Let's go ahead and try 32. Let me get it set to 32 here. All right. Hopefully this will make it over there. And we're going to see what happens here. Okay, and it is picking it up as 31.99. And yeah, this is, and the reference is reading 31.998. I'm going to give it a second here to settle, but yeah, I would say that's pretty close. So yeah, I'd give this thing a pass on DC voltage. All right, let's go ahead and try for the AC voltage test. We are in auto mode, so we're going to just keep on cruising. Let's go ahead and jam these in and see what we get. Okay, and it is reading it as 123 volts even. We're also getting 60 hertz for the cycle, for the AC cycle, for the frequency rather. So I would say that's pretty good. We'll do the frequency test later. I want to go ahead and start, let's go ahead and start doing some of the regular tests here. Okay, so we're going to start off, well, let's go ahead and try the continuity test. Okay, so here we're going to do the continuity test. Let's see what happens. Not very good. It is showing the resistance at least, and it's all over the place. So, yeah, continuity, buzzer, nah, I don't like it. Alright, let's go ahead and test some resistors here. Boy, this is going to be a real pain to do these. Alright, hopefully we can see all that in the camera. Alright, here is 10 ohms. Okay, we're getting a continuity. It does report solid continuity though in reading. 10.2, that looks good. Here's 100. Looks okay. 220. Pretty close. A little bit high. Not much. 330. Again, a little bit high, but pretty close. Alright, here is 1K. Getting 0.998. Alright, that looks pretty good. Okay, 2K. Okay, 2.012. Alright, close enough for me. 5.1. That's about where I was expecting it to read. Okay, 10K. 9.99K. Good enough for me. 100K. Pretty good. And 1 meg. Okay, and that looks pretty good. Let me get the substitution box down here real quick. Get this out of the way. See if it'll read up to 11 mega ohms. That's basically as high as I can go. So when we first put this in, we should get a continuity. Nope, we didn't. Now we do. Alright. Okay, so here is 2 mega ohm. Yeah, it's pretty much right on the money. 4. Looks pretty good there. Right about where I expected it. Alright, let's go up to 10. 9.96. Alright, pretty good. Alright, let's go to 11. 11 mega ohms. This is as high as I can go. Expecting around 10.97, 10.98, and 10.96. Alright, that works. That's pretty good. Okay, alright, so I'll have to give it a pass on resistance. Looks pretty good. Okay, so what I found out here is this does not do everything in auto mode. I thought it did, but it does not. It's pretty much like the HT112B. You can do resistance, which we just did, DC voltage, AC voltage, and continuity. So we're going to have to move this over to diodes. There we go. All right, so let's go ahead and do the LEDs here. Here's red with the reading. It's also doing that blinky thing that the HT112B does, so I guess that's just a common thing with these small ones. Yellow with the reading. Green with the reading, okay. Blue with the reading, looks good. White with the reading, okay, cool. And the RGB, there's your red. Whoops, let me get it plugged in. Get it down and hold there. Red, green, and blue. Okay, looks good there. Let's go ahead and do the diodes. Here is the rectifier. Okay, dot 564, no continuity beat. Okay, fast recovery, dot 524. These are pretty. This is pretty quick on the reading, so on the diodes. Schottky, dot 204, looks good. Okay, switching. And that was me, not the meter. Dot 624. Okay, looks okay there. And then finally the germanium, and we get dot 290. Yeah, a little bit high, but yeah, it's fine. Okay, I got my other Thsinde out here, so let's go ahead and measure the output voltage real quick before we move on here. And we are getting, wow, 3.982, and it's doing the same cycling that the HT112B was. So I guess that's just common with these smaller ones. It's something about the design. Possibly the same batteries. I don't really know. But anyway, pretty good voltage output on diodes. Okay, I've got it in capacitance mode, so let's go ahead and do the capacitance test on the substitution box. We're going to try 100 picofarads here. And we are getting 90, so that's not too far off. That's pretty good. 150, that's about right on there. 220, that's a little bit off. 330, yeah, it's a little bit off. 470, yeah, it's okay. 560, yeah, kind of low. 630 or 680, yeah, it's okay. 820, yeah, it's reading these a little bit low all across the board. There's 1 nanofarad, that actually looks good there. 1.5, yeah, 1.5 is a little bit low, so yeah, that's okay. 2.2 nanofarads, yep, slightly high, so that's good. 3.3, this should be a little bit low, and it is. All right, so it looks good there. Let's switch over to the higher side of this. Here's 4.7, that's right on. 5.6, a little bit low. Let's go up to 10 nanofarads here. Yeah, that looks okay. 15, a little bit high as expected. 22, pretty good. 33, a little bit high as expected. Yep. 47, this should also be a little high, and it is. 56, a little bit low as expected. 68, should be more like 64. Yeah, I'd give that a pass. And 100 should be around 102, and we're getting 103.1. So pretty good there. All right, well, since this was able to read the really low the 100 picofarad capacitor on this, I'm curious to see if this is actually going to read this 22 puff on this. I'm not holding my breath, but you never know. So let's give it a shot and let's see what happens. If I can get these untangled without making the thing move. All right, there we go. And I've got them the wrong way, of course. All right, here we go. Here's the 22 puff. Let's see if we can get this to work. And yeah, it's not reading at all. Okay, here's 1 microfarad. Okay, read that okay. Let's try that 22 puff one more time. Give it a moment here. Yeah, it's not doing anything. All right, let's read the 47. This should come in at about 44 microfarads roughly. Kind of slow on capacitance. But it's reading it right. All right, here's 100. I do like this display, by the way. It does not wash out. It is not reading it, or I'm not patching it in correctly. Come on. There we go. That was me. My fault. Okay, that looks good. All right, let's go ahead and try 1,000. I'm wearing the wrong glasses. I'm having trouble seeing the holes, so I apologize for that. Okay, 942, 43. Yeah, I'd say that's good. All right, let's try the 2200 microfarad. Let's see what it does there. And 2.102 millifarads. Okay, I'd say that's pretty good. That's about pretty close to where I usually read this one. All right, let's try the big one. Taking it a while, but it looks like it is reading it and in the range I expected. So yeah, looks good there. I'd say pretty good on caps. Okay, here we go on with the frequency test. I do realize there's a little bit of a glare in the display of the meter, but it does not appear to be blocking out the numbers, so we're just going to continue on. Now, according to the manual, the frequency range for this particular meter is 10 hertz to 10 megahertz. So we're going to run a sine wave on it starting at 1 hertz and work our way up, and we are running with a voltage amplitude of 2.5. So here we go. This is 1 hertz. Okay, we're getting 9.92. Looks like it's coming up a little bit. Yeah, I'd say that's okay. This is out of spec for this meter though. It does vary a little bit. Well, it's made it up to 9.98. All right, let's go ahead and go up to 10 hertz, which is its actual spec. Looks perfect there. Doesn't look like we're going to get duty cycle. Just going to display that temperature. All right, let's go to 100 hertz. Oops. Okay, looks pretty good there. All right, let's go to 1K. Looks good there. All right, let's go to 10K. Looking pretty good there. 100K. Looks good there. Okay, let's go up to 1 megahertz. Right on there. Okay. Here is 5 megahertz. Slightly high. That could be my tone generator doing that too. I don't know. Here's 10. So this is right at the limit and it is right on. All right, well, as we traditionally do, let's keep going. Here's 11. Looks good there. 12. Looks good there. Okay, let's try 15. And sagging a little bit. Let's turn up the amplitude to 5. Let's put that up to 5 volts and see if that recovers. Okay, looking good there. All right, let's continue on. All right, let's try 16. Okay, good there. Let's go to 20. Looks good there. All right, 21. Still going. 22. Still going. All right, let's try 25. And not bad. It's still pretty close. Let's try 30. And we're getting 30. Wow. All right, let's try 40. What the heck? Oh, lost it there. Okay, let's go back to 35. Yeah, no good there. 32. Okay, it's getting 32. 33. Okay, yeah, we lose it at somewhere between 33 and 34 megahertz, but that is way above spec, so yeah. On this test, yeah, this thing definitely, yeah, one of the best performers I've had. Okay, and last but not least, the NCV and the live test. Let's go ahead and do the live first, so here we go. Interesting thing about this is I have to touch the ground to get this to work. Once I touch it, if I pull it out, it works. If I let it sit there, put it back in, doesn't work. But once I touch the black, it does work. Anyway, it does work. My recommendation for this would just to do it like this. That's going to be your best bet. Just use both probes. Don't touch it the way that I was doing it. Just don't do that. Okay, let's go ahead and go on to the non-contact voltage. So we're going to toggle there. Up. There we go. All right, so let me zoom out just a little bit so we can see that a little bit better. Okay. All right, so we're going to try the power strip. Wow. Full scale. And picking it up, wow, yeah, pretty sensitive. All right, let's try the overhead LED. Same deal. All right, so very, very sensitive on the non-contact voltage. So this would definitely be useful for that kind of application. Okay, well that's going to do it for the tests. So let's go ahead and move on to the pros and the cons. Okay, now on to the pros of the Thsinde / WinAPEX 128C digital multimeter. First and foremost, good accuracy on everything. A little bit weak on capacitance below 1.5 nanofarads, but otherwise it did just fine. It was good on diodes, it was good on the LEDs, it was good on resistance, it was exceptional on the frequency, did just fine on AC and DC voltage. Can't fault it. And the DC voltage readings are a lot more stable than they are on the HT112B, so that is a plus. It is easy to use. The auto mode does work well. This thing is not easy to film, I will might add, but hey, it is what it is. That's my problem, not yours. The manual is legible and well written. No complaints there. If I needed to reference something, I had no problems making heads and tails of what I needed to figure out. Surprisingly clean display. I love this. This is the best EBTN display that I've probably used out of the few that I have. I mean, this thing just has a really, and hopefully it's not showing a reflection, so I'm kind of rotating around. Also, very, very few washouts. There's one or two bad washout places. It's right about there, and I'm looking at it, but every other angle, it's just fine. So yeah, I really was very pleasantly surprised with the display on this thing. Last but not least for the pros, it's compact. This would definitely be usable as a mobile meter. Plus you get the little bag with it, which it's lying on. It would have been nice if it had been a soft shell case, but it is what it is. Okay, now on to the cons. Well, first obvious thing, permanently attached leads. I don't like it. These leads, these are not the tiniest gauge wires, which is a good thing, so they're a little bit durable, but the only thing I can say there is just be careful with it. Baby it. Because if you break them, you're basically going to have to, fashion your own replacements for them. It is somewhat slow on higher resistance and capacitance readings, but that is kind of to be expected with the lower end meter. That's pretty true of a lot of them. That's all I can say about it. Has no fuse protection. So do not use this on high voltage. Don't even bother trying with current. That would probably not be a pretty sight. I would recommend using this on 30 volts and below. That's what I would use this for. And of course that brings me to the next con, which is the meter cannot measure current. So if you need to measure AC or DC current, you're going to be out of luck with this model. One other thing that I don't like about this meter is there's no protective glove on this. It's just a hard plastic case. That's all you get. If you drop this, there's a very good chance you're going to damage it. So be careful. And that brings me to the conclusion of this review. The Thsinde / WinAPEX 128C is a decent meter with good accuracy on readings and a surprisingly clean display with very few washout angles. And also the display is not too bright, not too dim. I like it a lot. This meter would be usable as an electronics bench and or in the role of a household digital multimeter, but it is not a good choice for measuring high voltage as it has very, very minimal protection. Just keep that in mind if you buy this. Although it is a little bit slow with some of its readings, the accuracy makes up for this. And to be truthful, I see this meter more intended in a mobile capacity rather than as a bench or a household meter, because it does not have detachable leads, number one. Number two, it does not have a stand. And number three, it does not have the ability to measure current. So this is not a full-fledged true bench multimeter. It just isn't. But for the car, which you're primarily going to be checking voltages and resistance, it would be just fine for that. I do recommend this assuming that the user does not have a need for measuring current and isn't playing with high voltage. So overall, I would say I do give this a thumbs up. I do like this. I especially like the display, but it doesn't have everything that everybody might want. So just keep that in mind if you consider it. And again, it's a good meter. It's got good accuracy, but treat it with kid gloves. That's the bottom line. This is Sui778 saying so long and thanks for watching, and we'll catch you the next time. Today's flavor is the Thsinde / WinAPEX 128C. This is a tricolor display compact multimeter. Available at Amazon. I personally picked this one up for 23 bucks.